All right, final trig equation, and this is another one with a couple of tricks to it. So let's get stuck into it. We've got 2 sine x, I should say, equals negative cos squared x minus 2, and again with the domain given to us. So look, maybe similar to the last one, we've got multiple terms going on here. It's not just sine x equals number, cos x equals number. We might try taking everything to one side of the equation and see if that helps us out. Adding that cos squared x over gives us cos squared x plus 2 sine x, and we can add the 2 over as well, plus 2 equals 0. Now at this point, well, there's not really much we can do in terms of collecting any terms together. We've almost got, you might remember one of these tricks where you can sometimes solve equations that aren't quadratic. You can solve them like they're quadratic, and this almost has that structure to it. It's got that first term being squared, another term with the value, the sort of unknown, only appearing as a factor of 1, and then a constant. But our headache here is that we've got cos x and sine x in the same equation. But what you might remember, and you think about cos squared x, are there any rules or any tricks I could apply that have got cos squared x in it? If you think back to the Pythag identity, which says sine squared of x, or theta, or whatever you want to call the angle, plus cos squared of theta or x, so if those two angles are the same, that will equal 1. That's our Pythag identity. And that rule is going to be helpful here, because what we can say is that, okay, this means cos squared of x equals 1 minus sine squared of x. And I can take this and put it into my equation and just see if that looks any better. All right, so cos squared x in the original equation is now going to become 1 minus sine squared x. And that doesn't fix all my problems, but what it does do is gives me an equation with just sine x's in it, rather than having cos x and sine x and trying to deal with them at the same time. So usually we like the squared term to be positive, so let's tidy this up a little bit. Well, firstly I've got a 1 plus 2, so I might add those two together. But if I want that squared term to be positive, I might just multiply everything through by negative 1 here, so that I get positive sine squared x minus 2 sine x minus 3 equals 0. And this has that quadratic structure that we can use quadratic methods to solve this equation, even though it's a circular functions equation. What I'm going to say is I'll let sine of x equal, you can pick whatever letter you like, just anything not x. I'm going to call it a, and then my equation would look like a squared minus 2a minus 3 equals 0. And I can try to factorize that and solve it using the null factor law. Only two numbers with a product of 3, or whole numbers anyway, would be 3 and 1. I need negative 2a, so I need a minus 3a there and a plus 1a here. Yep, that looks like it's going to work. And so therefore a equals 3 or a equals negative 1, and then we undo that substitution that we've made and we say, okay, well this means that sine of x equals 3 or sine of x equals negative 1. If you think about the equation sine of x equals 3, well, graphically what y equals sine x does is it starts from the origin, goes up and down like that, a bit wonky. The highest value it gets to is 1, lowest value is negative 1. So does sine of x ever equal 3? No, it doesn't. So this has no solution. But we know that sine of x can equal negative 1. To solve sine x equals negative 1, we think of our unit circle. We know that the sine x values are read from the y-axis, and so we're looking for where does y equal negative 1 on our unit circle, and that's down here at 3 pi on 2. So therefore x equals 3 pi on 2 is a solution. It does sit within the domain of 0 to 2 pi. The period of the equation sine of x equals -1 is 2 pi over 1. So the period's 2 pi. If we think about adding 2 pi, subtracting 2 pi to this number though, both of those are going to give us a value that's outside the domain. So in this case, we just got the one solution, which is x equals √3/2.